And let's hear the first talk.
Let's start with first talk, which will be given by Marek Brynda, and the talk is Scalable, Secure, and Sustainable NatWest Group's MLOps platform. So, stage is yours.
Okay, thank you. So, as it has been already said, today we'll talk to you about the NatWest Group's MLOps platform, why it's scalable, secure, and sustainable. On a daily basis, I'm a data scientist at NatWest, and during the whole presentation, I try to show you the problems which has been faced at the beginning of the MLOps journey at bank, how they are overcome through the implementation, and I will finalize with some quick summarization of the whole listed solutions. So we may ask what NatWest is. It's one of the biggest UK bank, the Scottish banks, and it started migration to cloud about 2 years ago. So we are quite new to the whole cloud environment. And more about background. So the migration started 2 years ago. There were some problems like discovered during the migration procedure. Some of them have been just found out that we have to solve them. And before the migration, the bank itself mostly focused on developing the project. There were a lot of models which were developed, and during the migration phase, we slowly moved more to the MLOps approach, where we start to work with the already trained model and not train so many. Just to set up the stage, what is MLOps? I'm sure that you already know, but to sum it up, it's like taking the DevOps approach and using it for the ML models. So standardization, automatization, making sure that we can work faster, quicker, better, and repeat the given procedure. Here also I hope also already known the image showing the shift in the perspective from simple ML code, the whole environment, whole configuration, everything connected with the not only code itself, but also the whole environment. What you have to think about when you just set up the working product in the working production environment. And that's why this presentation is shown here. Challenges. As I mentioned at the beginning, I will talk a bit about the challenges which have been met during the initialization and setup of the environment procedure. I would also like to mention that I haven't been involved in the creation of the whole procedure. I started as a simple data scientist, but during the work at bank, my role a bit shifted to more of the data scientist slash ML engineer. And I started more active work with the ML environment and also seeing the problem itself. I moved from this middle of this chart to the whole of it, seeing not only the code itself, but also the whole environment and all other needs. So starting with the challenges, one of them was the maturity. As I mentioned at the beginning, there was mostly developing the models. We started migration to the cloud. There hasn't been a lot of people experienced with the MLOps approach. And also mostly developer staff, developing the model, then not really, there was not a lot of people specialized at taking care of the model after the development. Processes, most of them have been done manually due to the fact that each of the team could have their own approach. The governance has been done also by hand, and it also involved a lot of people during the whole procedure. The whole story of the taking the accesses and granting the accesses took a lot of time. A lot of people were involved in the loop. Data itself, also a lot of requests, a lot of accesses, and a lot of different sources of data. And it also caused that before the project could really start, it took even few days to collect all of needed privileges. And technology, each of the teams could have their own approach, their own packages. Sometimes they were outdated, and it could cause at the end the problem with some migrating and developing the code to the production environment. That's about the challenges, and here about the implementation of the solution itself. So here, as you can see, and one of the reasons why I'm giving this talk is like that I think whole AWS environment and AWS solution, but as you can see, it's quite complicated, and my role on the daily basis is mostly data scientist slash ML engineer. So I will focus on some parts of this whole graph, and I will simplify it and try to talk to you about it as best as I can. So setting the stage up, I will start with some roles which have been provided during the whole MLOps platform creation. Two of them, the business one, the platform support engineer, more like reading person, can access, can read, but can't really interfere with the whole environment. The platform fix engineer, the second one, that's complete opposite, some kind of God mode in the environment. It's only granted for some limited time, and only when some problems appear during the development or during the development phase. And three main actors, technical lead, so mostly senior data scientists who got the access to the AWS service catalog, who can run and deploy the Amazon SageMaker environment, and just allow the only person who got the provision to start and move through the whole deployment and promotion procedure. The developers, so data scientists, data engineers, MLOps engineers, the people who work on a daily basis with the code and Amazon SageMaker environment, and separate role of the model approver, just to add one person and shift the responsibility also, just add one extra step, one extra just security reason that we are sure the person who just deployed the model won't accept their own model. Here, as I mentioned, the simplified version of the graph from the previous slides, and I will try to walk you through the whole procedure, how everything starts. So at the beginning, the technical lead. Okay. Okay, now, so at the beginning, the technical lead starts with the setting up the whole environment. It's done via SageMaker project. It's like no need to really contacting any technologies and a developer, just setting up the whole environment via filling the parameters and what exactly, like the name of the project, some simple information like what kind of template will be used. And by template, I mean that there's like no need of setting the whole environment. There are already prepared templates if you would like to use the classical sklearn models or some torch environment or some light GBM. We just choose which kind of environment we want, and then it will be created for us. And here during the creation, there's like security reasons. The whole environment doesn't have don't have the connection to the internet, the public internet. So the all Python packages, all of the Docker images has to be stored in the AWS code artifact and ECR from where they are downloaded to the Amazon itself. Further, after the setting up the whole environment, also the AWS cloud pipelines are set up, which provides the CD pipelines, and the developers comes in. They work with the whole SageMaker pipelines. It starts with the notebook environments. Then after getting some okay results, the acceptable results, they move to the migration of the code. And after migrating the code to the pipelines, it's the deployment starts. And deployment is just invoked via technical lead, via usage of AWS code pipelines, which provides the whole pipeline structure, and it ensures that none of the very important steps, so just unit testing, checking if of the standards, code standards, etc., are provided. So then if we are happy with model, if it has been trained, then model approver comes in, approves the model or not, and then the model goes to the pre-prod account. After getting the test done, if everything works as we expected, then the model is promoted to the prod account, and it can start giving them business value. Here listed some of the advantages of this solution. So already mentioned that self-service secure infrastructure deployment. There's like no need of contacting any technologies team, just not asking, okay, set up this kind of environment. Everything is done automatically. Central Python packages management system, which allows to having pre-approved, up-to-date Python packages, which helps with them, keeping the whole packages up to date, and keeping the technology in the newest. The CI/CD pipelines for model development promotion. As I said, they provide the whole needed infrastructure, making sure that none of the steps during the training of the model, the promotion, is not skipped. Code standardization and testing capabilities embedded inside of the pipelines itself. Model decoupling and orchestration. I will talk about it a bit later when I try to talk more about the SageMaker itself, but those functions allows to work with, for example, during the development, we can work with each steps at time. We can easily just audit each of the steps during the training or infrastructure phase. And quick start generic templates. As I mentioned, they are already provided by the via Amazon internal team, and they are prepared with all needed packages. The environment is set up, so then it's easy to start working. But it's not like this that we got only like listed packages. We can work only with them. If there is the need, there is always the option to just develop our own Docker image and then access via the shared AWS shared account. Okay. The main actor in this in the whole MLOps asset is the SageMaker, but there are also other roles to play. So as usually in the big companies, some internal packages provided by the developers, cloud services, which are already listed. So S3 for storing the data between each of the steps, cloud artifacts to get the packages there, code build and code pipelines to work with the CI/CD pipelines, and Lambda case if we want to have more live, not patched version of running the code. Machine learning, so due to the fact that it's a bank, we mostly work with the easy to explain models, and the fact that we work on a daily basis with the tabular data, which makes the scikit-learn package and mostly some XGBoost, LightGBM, tree-based approaches to be used. External packages, even though that SageMaker provides a lot of it's like end-to-end solution allowing to start working with the project, develop it, monitor, and detect, explain and detect biases, and etc. We still sometimes want to use different solutions. So TrueError, which also allows for the drift detection, bias detection, and some people just prefer to work with this. CometML for the tracking of the experiments, Airflow for orchestration of the whole pipeline itself, and Streams, and also for getting the data. Like those solutions are also used because not all teams work in cloud. Some of the models are still developed or some people still work on prem. So using those solutions, make sure that can be integrated. Amazon SageMaker itself. So what are the advantages of using it? I will start with showing how the example one of the provided training pipelines looks like. Here some things like There's like no need to use all of these steps. Sometimes we need less of them, but splitting everything in many of them allow us to also easy modify it. And having the same starting point for each of the project also gives the good transition between the projects. So if we are moved to the different project, if we gonna to help on the other one, there we know how the whole project is structured, how it started. So reusability. So each of the templates is easy to modify by a data scientist. Each of the templates is built from the basic blocks. And as I mentioned, we don't really need all of those steps. We only need some of them. Most of them will be like pre-processing, getting the all data done. Model training, obvious one, because we want to train the model. Sometimes the condition step, if we want to make sure that each of the previous step are succeeded. Create model and model registry are the one needed for the whole integration with the whole SageMaker environment, and post-processing mostly used for the for the inferencing part. Here, as you can see, there are those main building blocks which allows for a customization. Due to the fact that they are separated, it allows also for if we would like to have the data split separate, we can just make it a separate step. If we want like to have some evaluation at the separate step, we can also keep it as a separate step. And it could because we would like to have different, like we've got different computational needs for each of the steps. And then splitting it, it also allows us to cut the cost, waste less energy, etc. Efficiency. During the development phase, we can work with each of the steps separately, working like starting with like the first one is so obvious one. But then if we move during the whole pipeline, we can just hard code the input for the next step and then work only with this one, not running the whole pipeline each of the times. This solution is provided because after each of the steps, we save the data to the S3 location, and it will also help us with the another functionalities. So the whole pipeline itself is also easy to audit. Then here there's screenshot of the how it looks like in the SageMaker itself. So each of the steps is separate. It's easy. It's like easy for a person who doesn't know what this pipeline is, how it's work. Just easy to just follow through it, and it's intuitive to work with it. Also accessing the logs and checking all of the information inside is easy that way. Also mentioned the saving to the S3 location. If we notice that something it's not working fine, if the code looks okay, if looks okay, but then we spot some difference, like something is not working exactly at the next stages, we can just go back, see if the data saved between each of the steps is correct, is as expected, and then you can easily just spot some problems where they are caused. Security. I'm working in the bank, so the security is quite important. We work on a daily basis with the personal information, personal data. So as already mentioned, the turn off of the internet access, like public internet access, has been done. And then just to make sure that we can work with the newest Python packages, like the desired environment, the code artifacts, and Amazon ECR has been provided to provide those functionalities. Explainability and fairness, there are also built-in functionalities in the SageMaker itself, but due to the reasons that we don't always work with the SageMaker only, and some people just prefer different solutions, different tools, the Truera is also incorporated. So moving to the outcomes, what were the outcomes of like introducing and just building this solution? There was like a DevOps driven approach, which allowed for the usage of the standardized CI/CD pipelines approach and easy to repeat model training and model orchestration. A modern toolset using the cloud, the newest technologies, security and controlled template environments where the data is where the templates are provided by the technology team. Easy access to data, moving the whole responsibility for providing the data from data scientists itself more to the data engineers and just making the S3 as a main source of the data for them, and training data scientists and data engineers across the bank with the MLOps approach. So, for example, me. And going back to the previously mentioned problems or challenges to overcome, they were overcome and the outcomes are the modern tech stack. Simplified data access, like modern tech stack is, I think, explainable by itself using the cloud solution. Simplified data access, moving the data to S3, just data scientists don't have to worry about all of the accesses. They need only access to the specified location in S3 connected with the project itself. Optimized governance and standardized patterns, which make easier, which were provided by the standardization, making sure that most of the things are created automatically and people don't have to worry about. And at the end of the day, it just led to the faster time to value. Okay, thank you. And if you got any question, it's time right now.
Does anyone? Oh,
Yes, we have a microphone coming.
Thank you for presentation. I have a question. Do you have any plans to add in some tool for monitoring model in production already deployed in order to monitor some data shifts, something like that?
Yeah, so right now it's provided for example, in project where I worked, it has been provided by in an inference pipeline, just thinking what data I want to collect, and then just saving it to Snowflake environment and using Tableau dashboard just to monitor them. So it's not embedded in the SageMaker, it's some external solution for this.
Thank you.
Thanks for the presentation. So I have a question related to the SageMaker pipelines, and the question is, how do you scale up data processing or data pre-processing there, besides obvious reasons to scale up the machines that you run on?
Okay, so if we expect that the data volume will be large, it's also the solution that we move the responsibility for providing the pre-processing to data engineers and only start, for example, from inferencing step, which works in the batch manner. So it automatically just creates multiple different instances and just process the data in the batches. And it also allows to we can also work with this few different instances, but the simplest way is just, okay, data engineers just work with the large volume of data, build some Spark approach, something which is designed for the dealing with the big volumes of data, and we start only from inferencing and all data quality checks is on your side.
Thanks for the presentation. Was it difficult to plan the budget for the project, or was it a surprise to you?
As I mentioned, I wasn't involved from the beginning. I just joined, I started joining the MLOps team during the phase after it has been after the whole platform has been released. So unfortunately, or fortunately, I wasn't involved in those discussions.
Hi, Marek. Thanks for the great presentation. I have a question regarding the approval of the model. I would like please to know more about how long it takes, how many people involved in the approval, and what is the motivation to keep it manual instead of automated?
Yeah. So I'm not sure how much can I tell. So so I try to make it simple. based on my experience, the most annoying, the longest time is after getting the model and just making sure that stakeholders are happy with it. There's like a lot of documentation about the model, about the problems which we can face, the explainability to the stakeholder business users. So it's a manual procedure because we work in the bank, and if we make any decision based on the model, there is a chance that we will have to explain the outcome to the clients. For example, we would like to use this to give them the credit loan or something like this. So it's a long procedure, and it's I'm not sure I'm answering directly your question. So it's a very long procedure, and it always has to be very well documented. So it has to be in some way manual.
Hey, thanks for the great presentation. I want to ask about, I think that was mentioned on one of the slides, fairness. So how extensive is this fairness evaluation? Since you're a bank, I guess that's kind of important.
How extensive? It depends on the model. For example, if we are planning some marketing campaign, then it's like we are like I'm just thinking how to nice explain answer to this question. Like how accessible it is. So in most of the cases, we just try to determine if like start with just excluding all of the personal information, like easy to guess, gender, sometimes gender, age, sometimes the like also not using the location of the given person, and I'm not really sure what kind of answer do you want. So
I was mostly thinking about using any fairness metrics to evaluate the model afterwards, the predictions, and then if you're using any fairness mitigation algorithms, but it might be like a step too far. I mean, it's
yeah. So I use like right now I hasn't been involved like directly into the fairness part, mostly like some other more technical roles. So unfortunately, I'm not able to answer this question.
Sure, no problem. Thanks.
Thank you. First of all, thank you for an interesting presentation. My question is how, like, assuming that on this slide you have a pre-processing step in SageMaker, how do you do same pre-processing for inference for deployed model? Like, assuming that you have raw data as an input, how do you prepare its features for deployed model?
So mostly we assume that I think I can say that. Just like sometimes like this for sure, but sometimes it's just we are assuming that we know what is the set of the features. So as I mentioned, for example, we've got a great volume of the data. We just put the responsibility on data engineers. So provide us these given features, and we just go to the inferencing itself. And sometimes if you want something extra on our end, if you want like to add maybe some checks on the data on our end, or we just want to speed the process up because sometimes working with the data engineers on my experience is very slow. So then we can just decide this is the set of features which we want to use and just like hard code the operation which we are doing. So during the training phase, we making them like is experimental step. There is chance that if we run for different data set, we will get different set of the features, but inferencing, hard coding, we know what we would like to use. The other thing is that already mentioned, like model risk issues, that features which we are using has to be documented, so there is like no way of changing them and not providing the good explanation why we would like to use different features. So it's mostly hard-coded in the inferencing part. Yes. Yes, yes.